Okay, so today we're moving on to 10.4, inverse of a function. So inverse is when your input and output values are switched. So it means x becomes y and y becomes x. So inverse functions are functions that undo each other. So we know multiplication and division are inverse functions. We know that addition and subtraction are inverse operations. So there's an inverse relation and there's inverse functions. Today we're going to be looking at the inverse of a function. So what is that relationship going to be? Okay, so if they give you a coordinate point, the inverse of it is just where you flip the x and the y. So if I tell you in the original problem, you have the coordinate point 2, 3, the inverse of that would mean that it would have the point 3, 2. So that's what we're doing. We're switching our x and our y. So you've got 3 steps. Step 1 is if you've got an f of x, replace it with y. Step 2 is switch the x and the y in the equation. And then step 3 is solve that new equation to get y by itself. So when we were looking at our original equations and we wanted to know whether it was a function, we used the vertical line test. So if you guys remember, if we have our function, the vertical line test said that if we drew vertical lines and each vertical line only hit in one spot, we knew it was a function. So now if we want to know if the inverse of a function is also a function, we use the horizontal line test. So if I have the exact same graph, now I'm going to use the horizontal line test. The horizontal line test is the same as the vertical line test, but it's talking about the inverse of it. So if it only touches in one spot when you draw a horizontal line, then we know the inverse of that equation would be a function. This one, the inverse, is not a function. Okay. So number 1 says to find the inverse of the relation. So all that means is you're flipping your x and your y. So switch which one comes first and second. So this one would become 5, 2. This one would become negative 2, 4. This one would become 8, 6. And this one would become 9, 8. So if we're doing number 2, it just switches your inputs and your outputs. So all of your outputs would now go up for your inputs, and all of your inputs would now go out for your outputs. So my inputs would now be 4, 2, 2, 5, and 3. And my outputs would become negative 3, negative 1, 0, 1, and 3. You can always graph the original and graph the inverse, and you can compare the graphs as well. But if all it does is ask you to find the inverse, you're just flipping the x and the y. Okay, so in 3 through 5, it says solve y equals f of x, which means replace f of x with a y. And then it says solve it for x. So now I want to get x by itself. So all I have to do is subtract the 3 from both sides, and I have y minus 3 is equal to x. Then it says to find the input, so find x when the output, or when y, is 3. So if I plug in a 3, I get that x is 0. So those are the 2 things it asked me to find. So go ahead and try number 4 and number 5. Okay, so number 4, I replace f of x with y. Now I want to get x by itself. So I'll add a 2 to both sides. And then to get x by itself, I need to divide by 3. So I get x is equal to y plus 2 over 3. If you wrote it as a 1/3 y, 1/3 y plus 2/3, that's the same thing. So either one of those is okay. And then if I solve it when the output is 3, I'll plug in a 3 for my y. So I'd have 3 plus 2 is 5, so I would get x is 5 over 3. And the last one, replace f of x with y, and then divide by 4. So I have y over 4 is equal to x squared, and then take the square root of everything. So I have the square root of y over 2 is equal to x. Now, when you're taking the square root, remember you're going to have 2 possible answers. So we're going to have a plus and minus sign in front of it. So when I plug in a 3 for y, that means I get plus or minus the square root of 3 over 2. In other words, I would have x is equal to the square root of 3 over 2 or negative square root of 3 over 2. You can write it either one of those ways. And I could always simplify it. The square root of 3 and then divide by 2 would give me approximately 0.87. And I'd have the positive and negative of it. All right, so now we're going one step further. Now it says to find the inverse of the function. So step one is still to replace f of x with y. But now I'm going to switch my x and my y. So y will become x will become y. And then I do the same thing where I'm now trying to get y by itself. So I'll add a 1 to both sides. So I get x plus 1 is equal to 3y. When I divide by 3, I get y is equal to a 1/3 x plus 1/3. And then I can graph both of those. So if I'm graphing the original one, it had a y-intercept of -1 and a slope of 3. So up 1, 2, 3, and over 1. So there's my original. My inverse has a y-intercept of 1/3 and a slope of 1 over 3. So I go up 1 over 1, 2, 3. Or I could go down 1 over 1, 2, 3. And that would be what the inverse looks like. All right, let's go ahead and try number 7. So I'll replace f of x with y. Oops. So I have y is equal to negative 3x plus 2. Now I'll flip my x and my y, and then I'll solve it for y. So I'll subtract the 2 over first and divide by my negative 3 next. I could rewrite that in a way that's easier to graph it. That would be a negative 1/3 x plus 2/3. So then if I'm graphing my original and my inverse, my original had a y-intercept of 2 and a slope of negative 3, so that'd be up 3, left 1, or down 3, right 1. So there's my original graph. My inverse has a y-intercept of 2/3 and then a slope of negative 1/3, so up 1, left 3, or down 1, right 3. And that would be what my inverse looks like. All right, let's do number 1. One more, number 8, and we won't graph this one, we'll just make sure that we can find the inverse of it. So try number 8, find the inverse, and see how you did. All right, so I'm going to replace f of x with y. And then I switch my x and my y. And then I get y by itself, so I'll subtract my 2 over. And then to get rid of multiplying by a fraction, I multiply by the reciprocal. So I'm going to multiply everything by 2, which gives me a 2x minus 4 for my y. Okay. The next section, it says to determine whether the inverse is a function and then find that inverse. All right, so let's find the inverse. So I'm going to replace f of x with y, and then I switch my x and my y. So I have x is equal to the square root of y plus 4. To get rid of the square root, I'm going to square both sides. So I get x squared is equal to y plus 4. When I subtract the 4 over, I get y is equal to x squared minus 4. So if I have x squared minus 4, and I think about what these graphs look like, and if I have the square root of x plus 4. So let's graph the square root of x plus 4 first. So I know that plus 4 moves it to the left 4, and then we know that my graph is going to look like this. So the inverse, when I graph it, is x squared minus 4. So it's going to have a y-intercept down at negative 4, and then it is my quadratic equation. So it's going to be that U-shaped graph. Now, one thing I want to show you is that I did it in dotted lines because I'm only actually going to think about this half of it. This half on the left-hand side technically isn't part of the inverse, and that's because the original domain of my original one, x could only be greater than or equal to 0. My domain is restricted because it's a square root. I was not able to have any negative numbers for x. So when I'm finding the inverse, I can't have any negative numbers for x either. So I know that my graph is only going to be when x is greater than or equal to 0, which would just be the right-hand half of that graph. So I'm actually going to erase this half of the graph. Whoa, I don't know why my graph is moving. That's weird. Okay, I'm just going to redraw it in. There we go. Okay. So the inverse, you can see, would be symmetrical. If I were to draw a line right there and fold it on it, it would be symmetrical. All right, so on number 13, again, we want to think about our domain on this one. So if I think about setting 3x minus 9 equal to 0, and this was x greater than or equal to 4. I don't know why I put 0. The lowest x went was 4, so the lowest x can go as 4 on that one as well. Okay, so on number 13, we know that x can't be, we can't have a negative number under our square root. So if I set 3x minus 9 equal to 0 and solve it, then I get that x is equal to 3. So I know that when I'm looking at my graph, that 3 is going to be the farthest to the left it goes, and then it's going to go from there. And I don't care how quickly it goes up or down. I just want that quick general sketch. So then if I think about the inverse, so I'll replace x and y, switch them. I'll square both sides. Then I need to add a 9 to both sides next. And then divide by my 3. When I divide by 3, that's the same thing as a 1/3 x squared, and then plus 3. So if I'm thinking about the inverse of this, I know that my graph is going to be up at 3, and it's going to be my quadratic U-shaped parabola. It's going to be going up 1/3 as fast, so I know it's going to be wider than normal. But again, I'm only thinking about the inverse portion of it, which is just going to be the right-hand side. So I really don't want to do this part. I just want the left-hand side of it. So are the inverse of each of these going to be functions? Yes, they are. You can see they pass the vertical line test. You can think about the original graph, and the original graph, if it passes the horizontal line test, so my original graph was here, it passes the horizontal line test. My original graph is here, it passes the horizontal line test. So we know it is going to be a function that way as well. Let's do one more. Let's do number 15. So if I think about what the original graph looks like, it's got a vertex at 0. It's going to be going up 3 times as fast, so it's going to be nice and skinny. The inverse of that would be, does this pass the horizontal line test? As I draw my horizontal lines across, does it work? Well, as it's written right here, no, it doesn't. But let's take a look at when we actually find the inverse. So I replace f of x with y, then I switch my x and my y, and then I'm going to divide by 3. So I have a 1/3 x is equal to y squared, and when I take the square root of both sides, I get the square root of 1/3 x. Now, if I think about this, I know that the domain of this is restricted. X can only be greater than or equal to 0. If I get a negative number, it doesn't work. So what is this saying? This is saying that I have just this part of the graph. So only one side of my graph was I finding the inverse of. I was only finding the inverse of the parts where x was greater than 0. So the horizontal line test does pass if I think about where my domain is restricted. Because I know I'm not going to have this part down here, this part is not being switched, I can't have these values down here, it is going to be a function. Okay, take a second, write your summary. I think finding the inverse is something that it just takes a little bit of practice, making sure you've got those steps, knowing whether the inverse is a function or not, being able to think about that restricted domain. That's something that you want to think about a little bit more and probably come with questions tomorrow. Notice if it was originally a linear, the inverse is going to be linear, and so it's always going to be a function. So those, finding whether it's a function or not, is going to be a little bit more straightforward. You don't have to worry about restricting the domain like we did down here.